This is the introductory lesson to trig identities, proving left-hand side equals right-hand side. The formulas you will need are sine squared plus cos squared is 1, which I have rearranged as well to make sine and cos the subject of the equations. And then you also need to know that tan is sine on cos, and we have a rule: when in doubt, tan is sine on cos, and that works whether they are squared or they are not squared. Right, so the idea is to get the left-hand side equal to the right-hand side, or vice versa. The left-hand side is more complicated, so let's write it down. Do not use the equal to 1 any further in your question. You will lose marks if you do. Right. So my left-hand side is that. I can see that 1 minus cos squared can be written as sine squared. Put it over the original sine squared, and they cancel down and give me 1, and the left-hand side equals the right-hand side. So let's get the lines sorted out and the colors sorted out. Right, the next one little step harder. You may not square root anything in maths that has adding and subtracting underneath the third. So let's go with the left-hand side, and we're going to change 1 minus sine squared into cos squared, because now it is legal to find the square root of that. Put it over the original sine. The square root of cos squared is now cos on the original sine. And if you have a look on the right here, tan is sine on cos, so cos on sine is 1 on tan. And therefore my left-hand side equals my right-hand side. Let's go and sort that. Right, we're going to work with the left-hand side because it is far more complicated. I also see that I have a tan here and a tan there, so I'm going to use the formula tan is sine on cos. So we are going to be left with, on the left-hand side, sine squared x on sine x on cos x times by cos x plus cos squared x, tan is sine x on cos x, and that's all on sine x. Right, I'm just going to sort out my lines and my colors, and we will continue. Right, let's see what cancelling we can do. Just be very careful. I see a cos under the sine and a cos over 1. I then see a sine squared on a sine, so that sine will cancel with the square. On this side, I see a cos under the line and a cos squared above the line, which then leaves me with the sine, which cancels with that sine. And I am left with, on the left-hand side, sine x, and on the right-hand side, I'm left with cos x. Now, if you're not good at cancelling, rather tip and times these, but not past the plus sign. Tip and times next to the numerator there, and tip and times the sign next to that, and then everything will be on a level easier to see the cancelling. But if you can cancel, just be very careful. So my left-hand side equals my right-hand side. Right, this next one on the left is more complicated. Even though the right looks more complicated, it's because of the powers. This is a sum of cubes which you have done since grade 10. So the left-hand side is going to be sine x plus cos x and then you open the bigger bracket, which is squaring the first one, sine squared x, multiply and change the sign, so minus sine x cos x, and then square the last is cos squared x. So I have factorized cubes. Very important. This trinomial here never factorizes again at any stage. So we call it useless, just to remind ourselves not to try and factorize it. Right, having a look at that, I have got almost what I need. I am just looking for the 1. So this 1 that I'm looking for on the right, I see sine squared plus cos squared. So that is going to give me the 1 that I'm looking for. And the rest has fallen into place. So that is sine x plus cos x. Right, and then here sine squared plus cos squared is 1 minus sine x cos x. So the right hand side guides us. The whole right hand side guides us because they could ask for something different. So keep your eye on the right hand side. It definitely helps you do this. And yeah, it actually is a very simple one. It looked difficult to start with, but it's not. Right, the next one, the left-hand side, I see dots. I see high powers. It's normally left that we try and get to right, but it doesn't have to be. So I'm going to do the dots, which is going to give me sine squared A plus cos squared A and sine squared A minus cos squared A. Right, that is supposed to be an S. Right, so my dots here have given me what is called a conjugate pair. Right, if you have a look here, you will see sine squared plus cos squared. So that is going to give us the 1 that we are looking for. And then here, sine squared minus cos squared. Sine squared minus cos squared. Keep your eye on the right hand side. The right hand side says I only want coses. So I'm going to take sine squared and I'm going to make sine squared 1 minus cos squared minus the cos squared that's already there, which then gives me, you can drop the 1 on the outside, 1 minus 2 cos squared A. And here again, you need that right hand side to guide you, because you could have been asked various answers, and if you don't keep your eye on the right hand side, you'll end up with an answer, but it might not be the one that they want. Right, so what we've had here is left hand side equals right hand side. And I think in question 4, I forgot to write that. Left hand side equals right hand side. Right. Right, the final question for this worksheet is number 6. I see a tan squared, so I'm going to make tan squared sine squared on cos squared. I'll put my lines in later. They go so skew, and sine squared x. Right, I'm going to get an LCD here of cos squared x, which leaves me with sine squared x minus sine squared x cos squared x. I now see that I can take out a common factor of sine squared x, which leaves me with 1 minus cos squared x, still on cos squared x. And then that sine squared x I'm going to bring down, and the 1 minus cos squared is sine squared, and it's all on cos squared. And carrying that on over here, that is going to give me sine to the power of 4x on cos squared x. And that is done. Let me go and sort out my lines quickly. Right, so we LCD'd, and then we saw that we had a 1 minus cos squared, which became sine squared, and then the sine squared times sine squared became sine to the 4, and therefore my left hand side equals my right hand side. Right, our next worksheet on this will lift the level. We're probably going to have to do 4 worksheets on this. Sorry it's all squashed in. I hope you've learned something beneficial, and see you in the next worksheet.